Good morning, welcome everyone to this session number 310. Today I will continue trying to understand this problem because I didn't understand completely. Yeah, and yesterday I submit for error this, and I don't know how mark this problem as a unresolved. But well, today I will continue with this problem. I am trying to understand, and I think that is because I am confusing the index with the value in the elements. Yeah, and basically this is the answer. But even with the answer is a little complex for me understand, and it's for the reason because I am confusing the index with the value in the queue. It's a big problem. Let me delete this and this, and yeah, basically this is our solution, or the solution of our solution. Okay, got it. Now for this code or this solution, the idea with this problem is discover how many slots we can have with water with these containers. You know, this is one slot, 2, 3, 4, 1 and 1, and 3 plus 1, 4 plus 1 plus 1 is 6. This is the idea. Okay, now for this, the first point is that the queue help us to, it's a data structure that contains the characteristic of the LIFO and FIFO at the same time. Yeah, this is the important point. Next to is that for this I will draw a little bit, and for this I need a little space here, and okay, it's enough. And next to I will put here the index. The index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now let me change the color for this. Okay, got it. Now the first that is have the answer in 0 and index in 0. Basically the answer is a cumulative of the slots. Yeah, and the index is basically we only move in the left to right with a while, but can works exactly the same with a for, but is move only in this direction. Yeah, this is basically the index. Okay, and obviously we start here. This is our field index. It's equal 0. Yeah, and the first is ask or q, that in this case or q, do you imagine that is here? Yeah, this q contains elements? No. Okay, only add, and the front is here. Yeah, this is front here. The index is 0. Yeah, index, and increasing 1 basically is move to the next. Yeah, now we have the value of 1. Okay, now again, the queue contains element. Yeah, contains 1, and the height of the current. Do you imagine that these are buildings? Yeah, do you imagine these are buildings? The current height, because it's high in the index, that is this, that is 1. This is greater than the height in the index, the q dot peak. The q dot peak is basically the front here, and the index 0 is this, basically 0. Yeah, this size is greater than this. Yeah, okay, please remove this element. Yeah, and save in the top. It's equal index 0, and now is the queue is empty. Yeah, okay, don't do anything more and only add the index here. Okay, nice. Now we move to the next is this. Now the queue contain elements. Yeah, the current height 0 is greater than the height in the index, the queue.pick, that is this, the front. The front is 1. What is the value is 1? Okay. Oh, it's too bigger. This is greater than this? No. Okay, only at this index here in the front. In the front means that we need move this. Yeah, and now put the index 2 here. Okay, now move with the next is this, and now is again the queue contain element. Yeah, the current height, that is 2. Yeah, let me put 2 is greater than the height this in the index, the queue.pick. The queue.pick is 2. 0, 1, 2. That's 0. This is greater than this. Yeah, is greater. Okay. Now top, it's equal the index 2. Yeah, that is this. We remove it. Now is the queue is empty? No. Okay, you can continue. Now is calculate the distance. The distance, yeah, is index, that the index in this case is 3, less the queue in the peak, that in this case is this 1, less 1. This is the result. 3 less 1, 2, less 1, 1. Okay? Okay, index, it's equal 1. Yeah, this is the distance. Even if we can see here, for example, we are calculate between this, the index 1 to the index 3. Yeah, we only have one slot or one column, yeah, or one space. I don't know how to say that, but you have only one unit. Yeah, okay, this is the index. Now we should calculate what is the mean height between both buildings. In this case, we have a building of 1 and a building of 2. Yeah, we need to calculate this. Why? Because if do you imagine that obviously it's a container, you can put water until here, because this water could escape for this. Yeah, for this reason is necessary to calculate the mean, because with the mean you know that the max value you can fill is this, the 1. Yeah, it's only one example, forget a little bit this, but okay, the mean it's equal, what is the mean between the current building 2 or the queue.pick, that is 1, 0, 1, that is this, or 1. What is the mean? The mean is 1. Okay, now we should calculate the bonding height. What is the bonding height? Basically, we need this, yeah, for example, here min is 1. Let's hide in the top. What value have height in the top? Top is 2, 0, 1, 2 is 0. Yeah, basically is min that is 1 less 0 is 1. Even here, yeah. What happened this? Because do you imagine that you have, for example, here, here, and here, yeah. This is our top, and we know that between this and this you have one slope for fill, but you need obviously you can calculate 1 multiply for the mean height, that in this case is the same. Do you imagine that is 1, 2, 3, and 4 is okay. You can fill 4 slots here, but you need remove these slots to the final result. Yeah, in this case, for example, the humanity slot is the 2. Basically, the answer is okay. You only can have the possibility to fill 2 slots. Yeah, that is this and this. Yeah, for the reason we should do this calculus. In this case, the height is equal 1. The mean is 1 less height in the top, that the top is 2, 0, 1, 2 is 0, it's 1 less 0, it's 1. Okay, and now is calculate the total. In this case, the total is the distance, that the distance is 1. It's equal 1 multiply 4 the height, that in this case is 1. The result is 1. We are saying that between this is the first 0, next 2 is 1, next 2 is 0, next is 2. Yeah, we are saying that between this and this we have 1 slot. Yeah, that is this. Okay, let's put here and we can continue moving. Yeah, and obviously we can put the index 3 in the front of the queue. In this case is here. Okay, now the next that is the index 4. We need to ask, okay, the queue contain elements, yeah, and now this building that is 1 is greater than the build the building that appear in the index 3, 0, 1, 2, 3, that is this. This is greater than this? No. Okay, only add this value in the front of this queue. In this case is the index 4, and continue with the next. Okay, now the next that is the index 5, that is 0 is greater than the, in this case, index 4, that is 1. This is greater than this? No, only add this value here. Yeah, in the front of the list. Even let me move here. Okay, and move with the next. Yeah, now we are here and we need ask, okay, the queue contain elements. Yeah, now the current index or the current building, yeah, in this moment I am using this reference as a buildings, but for the current barrier, that is 1, is greater than in the number 5, this is greater than this. Yeah, okay, now here me delete this. Okay, now we need take this element, the 5, and now in this case is remove it. Okay, the next is ask the queue is empty. No, it's not empty. Okay, got it. Now is calculate the distance between this element and the element that appear here and 4. Yeah, between 6 and 4, what is the distance? We know that it's only 1. It's possible only have one slot that is exactly this. Yeah, but it's necessary calculate. Now for calculate this is basically the current index that is 6 less this less 1. Yeah, in this case is 6 less 4 is 2 less 1 is 1. Yeah, basically is this. Only one slot to fill. Okay, now we have the distance is 1. Okay, now the next step is let me delete this. Okay, now the next step is calculate the mean. What is the mean barrier or the mean building between this and this? Yeah, and the current building is this is 1, and the in the index 4 is this 1. What is the mean? Well, it's still in 1. It doesn't matter. The mean is 1. Okay. Now is calculate the height. In this case is mean, that is 1 less top. What is top? Basically top is this element, the element that has been removed before. Yeah, in this case the top is 5, is this. If we replace this value is mean, that is 1 less 0, it's equal 1. Okay, and now the final is calculate the distance, that is 1 multiplied for 1, it's equal 1. We are saying that between this and this we have only one slot to fill. Okay, and before to continue we need check if the current in the current building that is in the index 6, that is 1, is greater than this. In this case that is another 1. No, okay, it's stop this while and only add in the front here the index 6. Okay, and we can continue. Move to here. Now appear a building with I don't know how to say that. The greater value in this list until now, that is exactly this. And we need to ask the queue contains elements, yeah, and now the current building that is 3 is greater than this index 6 is 1 is greater, yeah, okay, we need the first is this, we need to remove it to the queue and put here. Okay, now the next is ask the queue contains element until now, yeah, contains the elements. Okay, now we need to calculate the distance. The distance is between this building and the index 4, this. Yeah, what is the distance between this? In this case is 2, but we should calculate here. The distance is index 7 less this 4 less 1. Okay, in this case is 3. 3 less 1 is 2. We have 2 slots to fill. Yeah, in this case, the slots are here. Okay? Got it. I don't know why appear the balloons when I do this. Well, the next step is, okay, we have the distance is 2. And next is calculate what is the mean in the container. Again, because if you have one container here and one container here, you can fill the water until here because basically all the water escape for here. Yeah, you have the mean for contain. Okay, now is calculate the mean. What is the mean between three that is our current building and the building in the index 4 that is 1. What is the mean? The mean is this. Okay, and now is calculate the height between these elements. You know, in this case is mean less, and in this case appear the top. The top was 6. In this case is 1. Sorry, is 1. Mean is 1 less. This is an index. Index 6 is this. Is 1 less 1. It's equal 0. Okay, let me continue because here appear as 0. Distance is 2 multiplied for 0, it's 0. Yeah, we are saying that between this and this, yeah, even makes sense because if you notice, we are here. Yeah, this is our current subarray. Yeah, it's 1 0 1, and the next is 3. This is not counted because was removed previously. Was calculated previously. This is ignored. And for this reason appears 0 because basically this is marked as a field, or I don't know how to say it, but it's ignored. Yeah, and for this reason appear this. Yeah, 0. It's not possible to contain any water because basically you don't have another barrier. Yeah, if this appear here, well, you have this possibility, but in this case it's not. Okay, yesterday I had this question, how mark this slot as a market or field. Yeah, but in this case is with this stack. Okay, now okay, is 0, and we need as again 3 is greater than the index 4 that is 1. Yes, is greater. Okay, now the first is let me do the calculus here. The building 3 is greater than, this is an index, the index 4 is 1. No, sorry, I remove top. The top. The top was 6. This. No, yeah, we are good. Let me only remove this and this and this. Yeah, and this while is still execute because basically the current height that is 3 is greater that, in this case, the index 4, that is this. Yeah, 3 is greater than 1. Yeah. Okay, remove this and replace as a top. Now here is remove and here is put here. Okay, and now we need ask the queue contain elements. Yeah, it still contain elements. Now is calculate the distance. The distance is the index 7 less 3 less 1. In this case is 4 3. Yeah, previously was 4. Okay, now is 3. Distance is 3. Right. Now the next that is what is the mean between this and this? Okay. Okay, the current is 3 or the index 3 that is 2. What is the mean? The mean is 2. Okay. Now is calculate the bounding height. In this case is the mean. That the mean is 2 less height in the top. The top is 4. In this case is number 1. Yeah, 2 less 1, it's equal 1. Okay. And now is multiply the distance. That the distance in this case is 3. Multiply 4, 1, it's equal 3. Okay. 1, 2, 3. Now let me check with draws what is happening here. We are in this index and until the 3. Yeah, we are trying to calculate this. Let me draw here. The first is 2 until 3. The first is 2. The next is 1. Yeah, the next is 0. Okay, the next is 1. And the next is 3. Yeah, and we are calculus between this and this is say that the distance is 3. We have 3 slots, 1, 2, 3. Okay, and next to is calculate the mean height between these buildings. In this case is 2. And next to is calculate the bounding height mean. Mean that is 2 less top. The top was 4. This. Okay. Yeah. Do you see that in this case, for example, we have these 2 bigger barriers? Yeah. The first is with 2 and this is with 3. The first point is calculate the mean of this barrier. The mean is in this case this. And now this height that is 2, we need rest. What is the slots that are filled before? In this case is the slot is 1. We are saying that basically we have only this space for fill because the previous was filled or has been checked before. Yeah, in this case it's possible only fill this. That is 1, 2, and 3. For this reason appear this as a 3. Yeah, and I will continue with the next. Sorry. The next is in this case. No. Before this, Okay, it's 3 and okay, and now is calculate, no, we need ask the current is greater than the index uh, mm, the top is 4 is this. Now we need to remove this. Okay, now we need ask 3 is greater than the index 3 that is 2. Yeah, okay, we need to remove this element and put here. Okay, let me copy this and put here. Right. Now we need calculate, or we need ask the queue contain elements. Yeah, contain elements, contain the number 1, that is this. And next to is mean. It's equal between, what is the mean between this building and the building that appear here, that is 1, that had the value of 1. What is the mean? The mean is this. Yeah, okay, sorry, and the distance is 7 less this less 1. 7 less 1 less 1, it's equal 5. We are saying that between this and this we have 5 slots. 1, 2, 3, 4, 5. Okay, got it. And the distance is 5. Now is calculate the mean is between this and this. The mean is 1. And now the height is mean less height in the top. The top is the index 3. That means 2 is 1 less 2. It's equal less 1. Let me check here. Here. What is the index? The index is the 7. Ah, rayos. Okay, let me execute again. Okay, index 7 here. Mean is 1. And the top is 6. Why 6? Top is 6. I am wrong here. Oh my god. I still confusing the values, but I'm not sure. Okay, let me check the animation here. 6. I think that I will check the booger because again I am losing in one moment the values, but I'm not sure where. Okay, put here that that. Okay, we start here is 0, means that we don't execute this we don't execute this while because the queue is empty. It's only add on the front and appear 0. Okay, now the next time is the queue is empty. No, and now the current height, that is 1, is greater. Let me modify the code for integer current building. It's equal this. Current building, in okay, we start again. The current building, the first time is 0, means that it's not execute because this is empty. It's only add. That's it. Okay, this is our current building, the index 0. Now the current building have the size of 1. 1 is greater that even, let me create another DQ only for don't lose the values, because yeah, I confused with the index. And in this case, let me here head pop integer building top this is not here is dot push oh my god, in the index here, and let me change this for plural. Hates, yeah, I think that is this. Okay, yeah. Now we start here, it's empty. We only add the first building, that it's 0. Don't have nothing. Yeah, even here is 0. And move to the next. The next is the current building, that is 1. Is greater that height in the index this is greater, 1 is greater than 0, yeah, is greater. Okay, now we need to remove the top. In this case is the queue is empty, means that we only need a stop, and next to is add this value here. Okay, yeah, this is the index and the value. Okay, now we are in the index 2, 0, 1, 2. We are here. Yeah. Current building that is 0 is greater than 1. No. Okay, only add in the front. Even you can appear here 0, 1. No. 2, 1. And yeah. Do you see? This is the index, and this is the size 0, 1. Okay, now the next step is the index 3. The index 3, 0, 1, is this, is 2. Okay, 2 is greater than 0. In this case is greater. Yeah, we need to remove the top. The top, yeah, it's basically remove this. The queue is empty. No. Now it's calculate the distance. The distance is 3 less 1 is 2 less 1 is 1. Okay. And now the current building that is 1 and high in the index current building is 2 and 1. What is the mean? Is 1. Okay, and now is 1 less 0, 1, 2. In this case is 1. And here is the distance, that is 1 multiplied 4. Well, is 1. Okay, nice. Now we are in the index 3, 0, 1, 2, 3. We are here. Current building that is 2 is greater than 1. Yeah, is greater. Okay, we need to remove the top, remove here. Now it's empty and only add the index 2. Okay, and now we are here. Now in this number 1, no, sorry, the current building is 1. This is the size. Okay, this well, the queue is, the height is 2. 1 is greater than this. No, only add. Yeah, and the front. Yeah, even do you remember that 0, 1, 2, 3, 4? The previous was this and is put in the front. Yeah. Now is the index 5, 0, 2, 3, 4, 5. Here, this 0 is greater than 1. No, only add. Okay, 7, sorry, 6 is this 0, 1, 2, 3, 4, 5, 6. 6, that is 1. 1 is greater than 0. Yeah, is greater. Means that we need to remove. It's not empty because contain elements, and now is index that is 6 less 1. No, sorry, less 4 is 2. Less 1 is 1. Yeah, and now is between the current building that is 1 or index 1, 0, no, sorry, index 4 that is 1. What is the mean between 1 and 1? Is 1. And this is mean less height in the top. The top in this case is 5. 0, 1, 2, 3, 4, 5 is 0. Yeah, is 1 less 0 is 1. And here is the distance, that the distance in this case is 1 multiplied for 1 is 1. And now again, let's repeat this operation because current building is 1 and this is 1. No, it's not execute more, it's only add and move on with the 7 that here appeared this problem. The answer contains 2. Now is the 7. 0, 1, 2, 3, 4, 5, 6, 7. We are here. Yeah. This, well, the first that the queue containing element, yeah. This is greater than this, yeah. We need remove. And now the distance is 7 less 4 is 3, less 1 is 2. Distance is 2. Now the mean between the current building that is 3 or 1. What is the minimum? Is 1. Okay. Now here is 1 less height in the top. The top in this case is 6. 0, 1, 2, 3, 4, 5, 6. Is mean 1 less 1 is 0. And basically here is the distance. The distance is 2 multiplied for 0, 0. And okay, we need to check again. Current building is 3 and 3 is greater than 1. Yeah, it's again this. This is not execute, and the distance is 7 with 3 is 4 less 1 is 2. Okay, the distance here should be 2. 3, why 3? Is index that is 7 less 3 is 4 less 1. Index is 7. Only we have one element. 7. Yeah. 7 less 3 is 4, less 1 is 3. Now here between the current building that is 3 and 2, what is the mean? Well, it's 2. Okay, and now it's 2 less 4. 0, 1, 2, 3, 4. Yeah, that is 2 less 1, it's equal 1. And is the distance that is 3 multiplied for 1 is 3. And in this moment appear this 5. Okay, until now I think that I am following right this code. And next to is current building that is 3 is greater than, well, it's greater because this is only this, but it is only stop and add the index 7. Oh my gosh. Yeah, I think that basically with this, let me copy the image of here. I understand that when with this code is I think that it's a little complex for me because I still confusing the index with the values. But the idea is that okay, when you find an element, add to the queue. Okay, this case is 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, and it's the at this building here. Yeah, this case, this building of the one size. Next to is 0. Yeah, let me put here a 0. And when appear another barrier that is greater than this, basically is okay, remove this element. Yeah, this is an 0, and now calculate the distance between this and this. Obviously removing, it's only how many elements are, or how many slots horizontally are inside between this barrier and this barrier. In this case is 1. Yeah, the width, it's equal 1. Okay, next we should calculate the mean size between this and this. Yeah, in this case is 1. And now we know that we have we can fill at least one element, but it's important that of the t result that is 1, we need res how many other elements was processed before, or for example in this case, do you imagine that it's not water, it's only another barrier, it's not count. Yeah, it's 1 less 1, it's equal 0. We are saying between this and this it's not possible to have water or contain water, but in this case, for example, is 0. Yeah, is 1 less 0, it's equal 1. We have here we know that we have at least one element or one slot to fill with water. Yeah, but the tricky here is that what happened when, for example, appear here, is only add to the slot. For example, here this was removed, and yeah, when it's processed here, for example, and we have 1, we should remove this element. Basically is cut or map or graphic here. Yeah, now doesn't exist more these elements. Yeah, and move with the next. Currently or the queue contains a building with 2 slots. Yeah, the size. Now the next is 1, don't happen nothing. The next is 0, that is this, and the next appear this, the 1. And basically the idea with this problem is that you need calculate 2 things. If we want to represent this when this, for example, this are house and these are buildings. Yeah, basically with these algorithms you are calculate the water contained between house and next is containing between the buildings. Yeah, the first is calculate the water between the house, contain it between the house, and next two is calculate the water contained between buildings, avoid all these house. Yeah, do you imagine that we have, for example, another problem here? Now with this, for example, we have, I'm building here, and here one house, another house here. Do you imagine that is a house? Another here, and another here, and another here. Okay, and okay, the algorithms at the same time is calculate the water contained between a building and the house. No, it's no. This is wrong. Okay, forget this comment. The first time is we are calculate the water between house or houses. Yeah, between this and between this. Yeah, until find an element greater. Yeah, in this moment, for example, this is a building, but next is convert to a house, as a house. Okay, now is okay. Now this discard, and next to appear here. Now here is calculate between this and basically this. Yeah. Now in this moment, these both are houses, and we have 1, 2, and next between this and this. Oh no, but okay. Let me check. Here is this, and when appear a minor, don't do anything. Next to appear a minor, don't do anything. Next to appear this, and this is greater than this. Yeah. Now is this is calculate, and it's stop. Now move with the next, move with the next, move with the next. Now this is greater than this. Okay, we need calculate this, and it's remove, and now calculate with this. Yeah. Okay, now we are filled completely all the first row until this point. Yeah, and we have 3. Okay, now this is minor to this. Yeah, because basically all these are filled. Go to the next is minor. It's okay. Now the next is this building. Yeah, means that we need calculate this, in this case this and this, and next to no, we find this is remove, and we need to calculate the distance between this and this. The mean size between this and this is the same. Now is mean, that is 0, 1, 2, 3, 4, less this value 2, 4, less 2, it's equal to we are saying that we only have to fill this. Now is the distance. Distance is 1, 2, 3, 4, 5, 6, 7, 8. Multiply 4, 2. 16. Saying that we have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this is removed. I think that is because previously was filled when I was here. Is this with this? This is filled. And this is calculated. Yeah, 2, 3, 4. Yeah, it's filled until this. And now it's minor. Now go to this, is minor. And now go to this. And now here is distance between this and this is 1, 2, 3, 4, 5, 6, 7, 8. The distance is 8. Less 1. No, it's 8, sorry. Distance, it's 8. The mean between this and this is the same, is 4. The bond height is mean 4 less this that was removed before. Okay, no. Yeah, I got it. Yeah, until now here we are right, and current this is our front. Now with front this, basically calculate the distance between this and this is 1. Now is what is the mean between this and this is 2. Okay, now is basically how many slots we can fill, discount a previous process. Well, basically it's this and this. Currently we have 2, 4, 6, 8, 10, 20, 14. This is our current value. Yeah, and now well, when it's processed, basically is this is removed. Yeah, because in this moment all the elements until till distance is complete. Okay, and now is the last. The last is basically this with this. What is the distance? The distance is 1, 2, 3, 4, 5, 6, 7, 8. We have 8 the distance. The mean in this case is 4, 0, 1, 2, 3, 4. And in this case is reduced less this, that is 2. The size between this and this is 2. Yeah, and now is basically fill this element. Wow, it's a little tricky, but well, basically this is the problem. I think I will try in a few days or weeks after. I hope that can resolve, because was complex to me understand this. To be honest, I feel that is hard now to me try to understand this problem, but well, I'm trying. But well, thanks for watching this transmission.